This is my first Arduino project. It's a Arduino Shield board, and I had it made by a company called rpcb.com. They did 10 boards for 90 bucks, including 30 bucks shipping. Thought it was a great deal, and I'm really happy with their quality. Here's the board with some chips soldered on, and what it essentially does is use these Micrel M5451 chips, two of them, to create 70 outputs, which you can access through an IDE cable. I figured IDE cables are the cheapest way to get about 40 pins out of a board. And the Micrel acts like a, essentially like a ground side switch, constant current switch. And so it was originally made to run LED segment displays. And so what this board does is it takes a couple of inputs from the Arduino. Here you can select what the inputs are, and the way I did that was by putting a bunch of surface mount pads on the board, and the idea was you're supposed to be able to create solder connections across certain pads to short out certain connections and choose which pin you want. It turned out that that method is actually extremely difficult to make these solder pads. I think the pads are much too small. And then it also, the Micrels allow you to adjust the current across the entire chip. So I have a little current resistor here, and you can choose whether you want it 5 volts to go through that resistor for resistor selected brightness, or current brightness if you're connecting to LEDs, or if you switch this little jumper, then you can choose to drive the input voltage through one of the Arduino's PWM ports, and through that you can of course adjust the brightness of your LEDs through the Arduino itself. And of course I use these nice wire wrap headers so that you can put yet another shield on top of this one, or even stack these. And then I also have finally a separate power input, which if you pull this little jumper here, then the power that comes through here is only routed to these outputs, and if you put it in, this can also power the Arduino board. So you can kind of choose separate power or consolidated power. So this is of course the board connected up, and I got these huge IDE cables that circle all the way around and power a whole bank of LEDs here, some LEDs here. I ran out of wires to hook it all up, and then finally I hooked it up to this I wanted to show that you could use the system for driving logic, so I hooked it, 4 of these wires for the outputs, up to an L298N motor controller, motor driver. And so the Arduino is going to be used as the controller to drive this, and obviously with a total of 70 outputs you could drive 17 stepper motors, right? So the idea was to allow you to just basically run an obscene amount of outputs using the Arduino. So this is a little diagram of that logic. Right there you got the 5 volt in, a 1 kilohertz, kilo ohm resistor, and then that creates a logic which is generally good enough for most chips, and then this is your M5451 switch down to ground. And that's what the M5451 connection looks like there. You can pause that if you want to see. It's really simple. So let me hook this up. Plug that right in there. This is of course the Arduino with it connected. So now it's just running through a little single LED flip. Now you should see the brightness dimming. Let me turn off this light so we can see it a little bit better. And of course the motor is actually hooked up, so it's driving now different brightnesses using PWM to dim and brighten each LED individually, and with these 4 LEDs that are hooked up to the motor, doing that is actually driving the motor randomly, which is what you're hearing those sounds. And once the sort of LED demo is done, then it will drive the motor. Now it's showing like a marquee feature where it will just simply move a set of LEDs around, and the reason why it disappeared is because it kind of went off of my wires there. Now it'll go backwards, speeding up, and after this it will drive the motor. There it goes. I'm using like a rate relation algorithm to slowly speed the motor up faster and faster as it rotates around. And that's it. That's my first project.